Now, of course, we need to stay objective on simulation, and according to Pageant, again, there are some disadvantages of simulation as well. Okay, so when we check these disadvantages, there are some cases simulation is not an appropriate to use. For example, building a simulation model of a system requires spatial training. Okay, it is not as easy to create a linear programming model. Okay, so creating simulation model requires some training, and we need to understand many scientific or theoretical disciplines to create such simulation models. For example, if you want to create a discrete event system simulation model, you need to know a lot about the probability theory and also statistics. Now, it requires some spatial training, and if you ask different people to create a simulation model of the same system, that may be a little subjective, okay? So different professionals or experts in simulation can create totally different models of the same system. So this is a subjective thing. Model conceptualization is a subjective thing. So that is actually a disadvantage. But if you are really an expert, and even if your model is different than the other experts, usually the behavior of the models are going to be the same, okay? So that is a disadvantage that we need to be a little careful about, okay? I mean, if you are trained enough, if you are expert enough to create a simulation model, then there is no danger to use a simulation model. However, if not, in that case, we may have some problems. So the performance outputs of a simulation are also hard to interpret. Now, in the original system, we have some randomnesses, random factors, which we cannot model, and that random factors are going to stay random in the model of the original system as well. And the randomnesses in the inputs of the model will create outputs which are random as well. So you know from the probability theory. So if you have a random variable, and if you put that random variable in a function, in most of the cases, the output of that function is also random, right? So because of that reason, the simulation outputs, the simulation results are also random as well, and we need to interpret them statistically. Okay, we need to use statistical approaches to interpret the simulation results, and they are not fully reliable. You know, in statistics, you always come up with a confidence interval, right? So you can only rely on your results at a certain significance level, on a certain type 1 error or type 2 error. So you can only disprove your hypothesis based on these significance levels. So because of that reason, we cannot simply say the simulation results are 100% reliable. And simulation outputs are either estimates or approximations of the performance measures that are considered. So that is actually the result of the previous explanation. Because we have random inputs, the outputs may be random as well. Because of that reason, the original performance metrics that we should observe in the real system are going to be estimated with statistical results of a simulation model, okay? Or even if it is not a stochastic simulation, even if the inputs are not random, then the outputs are going to be deterministic, however, approximate values. Because if you are going to create a model of an original system, even though there is no randomness in the original system, still the model is not going to perfectly represent every aspect in the original system, okay? There are some aspects which you are going to omit, which you are going to ignore, which you are not going to be able to introduce in the model, because, I mean, creating a model as complex as the original system is going to create too many costs. It is not going to be possible for you, okay? So the model is just going to imitate the original system. It is just going to ignore some aspects of the original system. Because of that reason, the results of the model, they are also going to be approximations. I mean, even if there is no randomness in the inputs, the results are just going to be approximations of the original system performance metrics. Finally, another disadvantage is what? Simulation modeling and analysis can be time-consuming and expensive. As I have said, if you really want to create a simulation model of a system, it is going to take some time to conceptualize this model, and it is going to be a either medium length or long-term project for you. it is going to be time consuming, and it is also going to be expensive as well. And we are going to explain the reasons why it is time consuming and expensive in the following parts of this presentation file.